Hello everyone, this is Vijayasri, working as an assistant professor, Department of CSIT, MLR Institute of Technology. In today's session, we will discuss about DMA, Dynamic Memory Allocation. Overview of the session, what is DMA? Before that, we have to know what is SMA and Malloc program. What is SMA? SMA means static memory allocation, means the memory is allocated at a compile time. Let us suppose if I declared a variable like int a, okay, so the variable is of type integer. At compile time for this variable a, 4 bytes of memory is allocated. Let us see one more example, that is, suppose consider a array variable a. Size of the array is 5. That means this array can hold integer values. This array can hold 5 values of type integer. Suppose if I consider this is a memory for array, it starts with index 0, 3 and 4. So it can store up to 5 integer values. Each integer occupies 4 bytes of memory. So 5 values, the memory is allocated for these 5 integer values is 5 into 4, that is 20 bytes of memory. Suppose in this array, if I have given the values as 1, 2, 3, these can hold up to 5 values, but here I initialized only 3. So here it is 1, 2, 3. So remaining 8 bytes, in total it gives 20 bytes of memory, but I have initialized only 3 values. That means 3 integer values, 3 into 4, total 12 bytes is used. Remaining 8 bytes are wasted. And let us suppose if I want to store 7 values in this array. Already I have given 5, that means 20 bytes of memory is fixed. I cannot increase or decrease the memory in SMA. To overcome this, we have a DMA, Dynamic Memory Allocation. So before that, we have to know about a memory layout. Consider this as a memory layout. So the first segment is given for code or a text. The second segment is for global declaration variables or static variables. And the third segment is the stack. This is the stack memory. And this is the heap memory. This is a big pool of memory. It is called as a heap memory. So always these stack and heap grow in a opposite direction. If the stack is growing in this direction, the heap will grow in a opposite direction. Then let us consider a small program like int main. Always the program execution starts from main section, Then consider 2 values of type integer a, b. And here I am initializing the values of a as a equal to 10 and b equal to 20. Now whatever the values I have initialized, I am just printing those values using a printf function. Those are of type integer, so format specifier is %t, a, b. So if I run this program, first the control goes to main function. So on a sequence we have a, b values. So the memory allocated for these a, b values from stack. So in a stack, one stack frame is allocated to the function main. So consider this is the segment allocated to the main function from stack memory. So in that we have a and b, where a value is 10 and b value is 20. So after that we have a printf statement on the console. Let us consider this is the output console window. So there I am printing these 2 values, that is 10, 20. After I have reached to end of the program, once we are done with this program, automatically the memory which is allocated from the stack are freed. This memory will be freed. If I want to allocate the memory from the heap section, because this is allocated from stack, this is automatically, the compiler will automatically free that memory once we are done with this code. I want to allocate the memory for this using from the heap section. To allocate memory dynamically from the heap section, we need a pointer. We need a pointer variable, and also to allocate memory from heap section, we need a functions called malloc, cloc and realloc. Okay, suppose I'm considering one more example. Let us consider a pointer, because we need a pointer to allocate memory from heap. So to create a pointer is created, data type, pointer, then pointer name, let us suppose PTR. Using a pointer as well as using these functions, we can allocate memory from the heap section. So let us consider malloc of 8. Just simply I am taking for this as an example. We should not write 8 here. We have a syntax. Just for understanding purpose, here I consider malloc 8. That means I am telling to the compiler to allocate memory from the heap section of 8 bytes. 8 bytes of memory. So in this, 8 bytes of memory is allocated from the heap. On successful allocation, it returns the base address of this 8 bytes. So the base address, let us suppose 1000, it returns the base address. So the base address must be stored in a pointer. So PTR is equal to. Okay. So on successful allocation, it returns the base address. That address is stored in the variable called pointer. Now, once we are done with this memory, suppose here I have allocated 8 bytes, then I have done some executions. Once we are done with this 8 bytes of memory, then we have to use a function called free to free this memory. Because the user allocates this memory, then by using the free function, we can deallocate the memory which is allocated by malloc, calloc and realloc. Then the first function is malloc. So one of the application for the pointer is to allocate memory dynamically from heap section. We need a pointer, because pointer is having a property that it can store the address of a variable. Now coming to malloc, mainly this malloc function is present in the header file stdlib.h. If we are using a malloc, we have to include this header file like stdio.h. Then the next is, generally it is used for structures. And we need a pointer to allocate memory dynamically using the function malloc. On successful allocation, if the memory is successfully allocated, it returns a void pointer. Because we don't know. Because in this case, we don't know. Right now, we don't know which type of data value we are storing in that memory. So that when the memory is allocated using a malloc, it will return a void pointer. Let us suppose if the memory is not allocated successfully, then this points to null. It points to the null, means it is a invalid memory, or the memory doesn't exist. Now the syntax. And one more thing is, malloc takes one argument. In this malloc, we can write one argument. And it returns a void pointer, means void is having a property that it can store any type of value. Based on the programming requirements, we have to typecast that pointer later on. Then the syntax. See here we have the return type is void and the initial value. Let us suppose using a malloc 8 I have given. That means 8 bytes of memory. A single block. And one more thing is single block of memory. Single block is allocated. Let us suppose single block, that is 8 bytes of it, is allocated for that. If I did not initialize any value, it is uninitialized. So by default, it stores a garbage value. By default, the default value stored in it is garbage. Then the return type is void, default value is garbage. Now the syntax. So on successful allocation, malloc returns a void pointer. So void pointer. Then the function we are using here to allocate memory dynamically is malloc. Then it takes one argument. So n into size of data type. Size of data type. Suppose if I am storing a integer values I want to store. Suppose the integer number of blocks are 3. Number of blocks I want to allocate here is 3. Then, and in that memory I want to store integer values. So integer occupies 4 bytes of memory. Now we have to typecast this void pointer to integer values because I want to store int values. So int star. The function we are using here is malloc. Then number of blocks I want to allocate is 3. 3 into size of a data type. Here data type, which type of value I want to store here? Integer. So integer occupies 4. So in total 12 bytes of memory is allocated from the heap section. On successful allocation, it returns a base address. To store that base address, we need a pointer. So we have to write down as pointer. We have to write the syntax as, suppose example, ptr is equal to, I want to store integer type values. So int pointer. Then which function I am using to store allocate memory dynamically? malloc. It takes only one argument, that is number of blocks you want into then size of which type of values you want to store, integer values, then size of int. Then here we have an example. So I am allocating memory dynamically using a function called malloc. Syntax of malloc is void pointer, then the function name, then number of blocks into size of int. This function is present in the header file stdlib.h. So here I have included stdio.h because printf and scanf functions are present in that header file. Then I am using a malloc function which is present in the header file stdlib.h. Then always the program execution starts from main section. So on successful allocation of memory, it returns a base address. To store that base address, we need a pointer. Here n is the number of blocks I want to allocate, then I. So printf enter number of blocks. Let us suppose here I have given 2 blocks. So 2 blocks I want to allocate. Then n value is 2. Then ptr is equal to int star. Which type of values I want to store? Integer type values. So I am typecasting this void pointer to int malloc n, where n is 2 into size of int because I want to store integer type values. So 2 into 4, so 8 bytes of single block is allocated from the heap section. Suppose this is the heap memory, heap section. Then PTR, we have a PTR here. This PTR memory is given from stack. So on successful allocation, it returns a base address. If not, it points to null. So here I consider a condition called PTR equal to null. If pointer points to the null, means the memory is not allocated. If not, that means it returns a base address. Suppose the base address here we have is 1000. So 1000. This pointer is pointing to here in the heap. Then for I equal to 0, 0 less than n value here I consider 2. Then PTR plus I, where PTR means we have a base address, that is 1000 plus I, where I value is 0. But here it is a integer type. So integer occupies 4 bytes of memory. Then 4 bytes of memory. So it is 1000. So in 1000 I want to scan in the memory location. In the 1000 address I want to store the value as 10. So here I am storing 10. Next again I plus plus. Now I becomes 1. 1 less than 2 condition is true. Then scanf. The next value is 20. It has to be stored where? PTR plus I. Where PTR is 1000. 1000 plus I is 1. Where it is an integer type. So integer occupies 4 bytes. So in the location of 1004. In the location of 1004. I am storing the value 20. Now again I incremented by 1, then it is 2, 2 less than 2, condition is false. So the control comes out of this loop. So it enters into another loop. Whatever the values I have scanned and stored in this memory, I want to print those. Then again I 0, 0 less than 2, condition is true. Then I want to print the value which is stored in that location. I am not printing the address. I am printing the value which is stored in that particular location. So for that we have to use a dereference operator pointer PTR, where PTR value is 1000. In this loop I value is 0. But whereas this is of type integer, so integer occupies 4 bytes. So 0 into 4, now it is 1000, but here I used a dereference operator star. So I want to access the value which is stored in this location. The value stored in this location is 10. So it will be printed. Then next again I plus plus. Now I becomes 1, 1 less than 2, condition is true. Then printf. The next value which is stored in the location I want to print. So here %d, because it is integer type value, so the format specifier is %d, then PTR. PTR value is 1000, but I value is 1, whereas it is an integer type. The values are of integer type, so the size occupied by that integer is 4. So 1 into 4 is 4000 plus 4 is 1004. In 1004, I want to access the value which is stored in this particular memory location. In that location, the value stored is 20. I am going to print this. So after we are done with this memory, because we are allocating this memory dynamically from heap section using the malloc function. So after we are done with this memory, because I have read the values stored in that particular location and I have printed those values, I am done. So after that we have to free the memory. To deallocate the memory, we have to use the function called free, then the pointer, because this pointer is pointing to this location. So we have to give the pointer name. So in this session, we have discussed about what is SMA, DMA and a malloc function. The next session will go with the calloc and calloc and realloc functions. Thank you.